Chapter 10 is going to be about carboxylic acids and the derivatives of carboxylic acids. So, first of all, to remind you, this is what a carboxylic acid is. Carbonyl with an OH. And the derivatives, there's really kind of 5 derivatives. One is the acid chloride. Basically, all we're doing is we're keeping the carbonyl part of it, but we're changing the ending part of it. So that's the part that's going to change. The other one is an anhydride. Anhydrides, here is the carbonyl part, and then here is the new part of the anhydride. It kind of looks like two of the same molecules hooked together. So this is the add-on to the carbonyl. Next is an ester, which is an OR group. Another one is an amide, very important in biochemistry. You can either have 2 R groups, or you can have a hydrogen in an R group, or you can have 2 hydrogens. Any possibility. And finally, something called a nitrile. It doesn't have a carbonyl, has a triple bond end, but that technically is classified as a derivative of carboxylic acids, and it's in this chapter. We're going to quickly go over how to name these. The only naming that I want you to know for sure is the carboxylic acid. That will be on the exam or quizzes, how to name carboxylic acids. But how to name acid chlorides, anhydrides, esters, amides, nitriles, those are not going to be on the exam. But I'm just going to go over them just so I can say that I have taught you how to name them. All right? So carboxylic acids end in oic acid. So however many carbons you have, this should be kind of straightforward at this time. This is carbon 1, 2, 3, 4, 5. Your first carbon is always the carboxylic acid, so you don't need to tell the reader that that's the carboxylic acid. All right, so this is called pentanoic acid. Very straightforward. Okay, carboxylic acid is the highest oxidized atom, so that usually gets priority over any other functional group. Let's say you have a Cl and a methyl group right there. All right, so this would be 2-chloro, 3-methyl, and then 1, 2, 3, 4, butanoic acid. I don't have room here, so I'll write it down here. Butanoic acid. That's basically how you name acids. Very straightforward. Next ones are acid chlorides. Acid chlorides are the only type of derivative that exists. You do not have an acid bromide. That does not exist, nor does an acid iodide. So just acid chlorides. These end in oil chloride. Oil chloride. So just name the prefix, however many carbons you have, and then end it in oil chloride. Simple as that. This is always carbon 1, 2, 3, 4. So butanoyl. Kind of sounds funny, but that's what it is. Butanoyl chloride. Okay? Next one are anhydrides. Anhydrides are similar to carboxylic acids, but they end in oic anhydride. All right, and they're usually symmetrical, meaning whatever group you have on one side of the anhydride, you have exactly the same group on the other. So if you have 4 carbons here, you have 4 carbons here. If you have a cyclohexyl here, you'll have a cyclohexyl here. They're usually symmetrical. You can have what's called a mixed anhydride, but those aren't as common. Mixed meaning you have 2 different groups. But basically, whatever your group is, you just name it and then end in anhydride. So it's 4 carbons. So this is called butanoic anhydride. Simple as that. All right, if you have like cyclohexyl groups. All right, we're not going to learn how to do the mixed anhydrides, but it's basically you just name one group and then the other group alphabetically and then anhydride, but we're not going to do that. This is cyclohexanoic anhydride. Okay, and that's how you do anhydrides. Next are amides. All right, same type of thing. Carbon 1 is always the one with the carbonyl. 3, 4, 5, 6, 7. So this one is heptanamide. These end in amide. I guess I forgot to write that. Amide. Heptanamide. All right. Now there's a special way to name these, because what happens if you now have groups hanging off of your nitrogen? So let's say we have our chain. Right, here's 1, 2, 3, 4, 5. But let's say we have a methyl group hanging off of nitrogen this time. Well, you need to tell the reader that on the nitrogen you have a methyl group. The way you show that is by doing a capital N and then writing what group it is. So N-methyl. So on the nitrogen I have a methyl group. Then name it exactly how you would name an amide. Since it's 5 carbons, it's pentanamide. I'm going to come down here, amide. Not very good with space today. Okay, if you have 2 groups on your nitrogen, so let's say you have 2 methyl groups, you need to tell the reader that you have 2 methyl groups on the nitrogen, so it's N-dimethyl. Okay, and then this is 4 carbons, so butanamide. Alright, so this time if you have things on your nitrogen, you need to tell the reader that you have these other groups on your nitrogens. Next group is esters. Alright, esters end in O8. In an ester, you have 2 parts to an ester. You have the carbonyl part, and then you have the part hanging off of your oxygen. So here's the carbonyl part, and here's the group hanging off your oxygen. You need to tell the reader what this group is, because that could be any possible group. Then you name the rest of it as an O8. So this would be called ethyl butanoate. Right, here's the ethyl part, 2 carbons, and then here's the butanoate. Okay, and that's how you name esters. You just name this part first, and then you name that part second. Okay, and then obviously if you have other groups on it, you would name those accordingly, but we're really not going to see those. Finally, nitriles. Nitriles are triple bond ends, right? So an example of a nitrile. This would be an example of a nitrile. When naming these, you include this carbon. So this is carbon 1, carbon 2, carbon 3, carbon 4, and they end in nitrile. Very simple. So butanitrile is what these are called, not butanitrile, butanitrile. There are 2 ways of naming it. This is one way. Okay, so include the carbon in the nitrile. And that's basically a real quick rundown on how to name things. But like I said, the carboxylic acids are the ones that you'd be responsible for.